Hello, we're going to keep talking about alkene hydration, but this time we're going to be using a different reagent. And what we're using is borane. So the reaction, we need to carry out that, say, into stages. First, we use borane in THF, tetrahydrofuran. And so in the second step, we do an oxidation. So this is called hydroboration-oxidation under basic conditions. And what is important to remember about that condition is that when we add, say, that's my alkene, right? When we add to the double bond, remember this is hydration, so we're adding, I'll say, H and OH across the double bond. When we use this reagent, this happened with AntiMarkovnikov reduced selectivity. AntiMarkovnikov. And what that is, when it is anti-Markovnikov, then you're going to have the H being added at the more substituted, and in your final product, you're going to have the OH at the least substituted, so opposite of rigid chemistry. Another thing that is important about this reaction when we are predicting product is that this happens in syn fashion. What that means? Syn means that when we're adding across the double bond, both the H and the OHs are going to be facing to the same side. So maybe you're drawing wedges or dashes, so you need to make sure they are facing the same side. And so say that, let's do another alkene here. And that I use that condition again. So we do first borane, THF, second. What is going to happen then is that we're going to be adding the OH here. But what is the configuration? So essentially, we'll be having this. And that wiggle lines means that we're not specifying what is the configuration here. So now I'm going to erase on the top to make, say, a 3D drawing of that. So let's see if we can make that better. And so this is that. Here's much here. So let's try to make it. Let's say this is now in the molecule here is drawn like that. Now I'm doing it like so. So metal going in dashes and in wedges. And here I have a metal. And well, of course, here I'm going to have a hydrogen. So let's do that. So if this is on that plane, we can have H and OH, remember, needed to be added to the same side. So we're going to do, say, OH here and H here. That is what we're adding. If we do that, the product, let's say now we're going to do this, and we're going to have OH. Of course, the H will be added. Well, we can draw it, and then we'll remove it. What you will see at the end is the following. So here you had a metal, and you had an H. So remember that when we don't have anything, those are metal groups, these two metal groups, H, H. So this is what, notice that I'm drawing the OH and the H to the same side. I'm approaching that way. So that will be one possible option, but you could also have another approach. So this time I'm going to be erasing the bottom to do the other drawing. Let's say that you're adding from the bottom. And now let's do another color for that. So same thing, I'm going to draw my alkene. And that again, remember, if I don't draw anything, that's metal, metal, metal. Let's do now approach on the other side. And again, we're adding the H here and the OH, we're gonna add on that same size. The molecule is again like that, so we're gonna have the following. So I'm gonna do OH here. And when I do that, I'm gonna have metal, that's my H, and I'm gonna have this, I'm gonna keep drawing that so that we see that they're being added on the same side. So here you have the products. So notice that we can have those two. Typically, you won't see the hydrogens in your drawings. So what you will see is if you don't draw the hydrogens, this is not an arrow. Let's say that I'm going to draw just an equal sign. This will be this. And so that will give you the following again. We're not drawing the hydrogens. What we will draw for the molecule below, then we're going to do this. Now, which is here, dash, that's the middle. And here, I'm not drawing the H, so I'm drawing this two only. So let's do a better angle here. So that's what we are doing for the other carbon. Okay, so again, important things to remember. This reagent is used to do hydration, and it goes AntiMarkovnikov fashion, and that means that you're adding the H at the more substituted. Remember, how do we know more substituted? You have replaced hydrogens by groups, alkyl groups. In this case, you see this has two metal groups, so this carbon is more substituted than this one. This one has a metal and hydrogen. So AntiMarkovnikov means you're adding the H at the more substituted, the OH at the least substituted carbon. The molecule is drawn this way. You can approach from above, say, and from below. And you have here these two possible compounds. So these two will be enantiomers. So we're going to keep working on this.